Hi everyone, welcome to Module 1, Lesson 4, my first Python program. Now that we've installed Python and our IDE on our operating system, let's create our first Python program. Hello world. Our first Python program. I am on a Windows home machine. Now before we delve into Python and the IDE, or actually the IDE, let me just show you a little bit about Python. Open up our command prompt and we type in Python. We're in our Python compiler. Now in here, you can type Python commands and they will work. For instance, let's do the hello world example that we did out of our lesson. So if we type in print hello world and we press enter, the text is printed hello world, our first Python application from the compiler side. This is just to show you that you can actually test commands in Python in the compiler. For instance, if you want to check if you can add stuff, so you can say 3 plus 4 and enter, and it will give you the value of 7. So we can run commands in the compiler without running it through an IDE. What's difficult about this is the Python compiler doesn't show you where there's syntax errors or anything like that. So if we should type an error, we're just going to get an error, or if our syntax isn't right, we're going to get an error. So if we should say print hello world, note that I didn't close the double quotation marks, and I press enter, we get an error. With an IDE, it will tell us before we run the code that there is something, a syntax error in that line. We'll have a look at that just now. So let's exit this with Control Z twice, and we're out of our Python compiler. And let's close our command prompt. I just want to show you guys this as well. Let's open up File Explorer, C, and into our C drive. I'm going to create a folder here, a temporary folder. And in this folder, I'm going to create a file, first app. The extension for Python is .py, and that is our first application file. Now, I'm not going to open this with the IDE. I'm just going to open this with Notepad to show you guys that Python's files is normal text files that you can edit with any text editor as well. Again, you don't have the functionality with the text editors that you have with an IDE. So I'm going to say open with Notepad. And you can see our file has nothing in it. It's a blank file. And I'm just going to do a print hello world here. Gonna go save the file, and to run that file through Python, I'm going to open up the command prompt again. I'm going to that directory cd/tmp. If I list the files in that directory, our files there, first app.py, and to run this file, we use the command python space and then the file name, first app.py. And as you can see, it took that file into the Python compiler, executed the code, and printed the words hello world for us at the command prompt. Now let's look at that example through an IDE. If we go to our folder, and if we check the check boxes that said add the right-click commands to our File Explorer, we can right-click and we can say open with code. Now, in our code editor, in our IDE, we just have to allow and trust this workspace so that we can run the code through it. And then from there, you can see it did some syntax highlighting for us. So the print function is yellow, and the string text inside the parentheses, that's a different color. And to run this code now from out of our IDE, we can press F5, or we can go to Run, Start, Debugging. The IDE is going to ask us, what file is this? And we want to debug a Python file. So we select Python file. And as you can see, it opens up a terminal here that will execute the command for us. Now, all our results will be in this terminal. And as you can see here, it's printing hello world from our first app.py file. Now, just to show you the power that you have, and this is just in the beginning, if we should do that, our IDE is detecting that we didn't close that and there's an issue there. So if we go and we hover over that, it says that the string literal is unterminated. If we close the parenthesis, the error goes away and our code should execute without a problem. The syntax error has been rectified. If we have a couple of errors, we should see here, we'll see here about problems. We have two problems here, that the opening bracket wasn't closed and the string literal is unterminated. Just to show you guys why we use an IDE, why we use Visual Studio Code to help us code, so that we can actually find issues, problems, syntax errors before we run the code and get those nasty messages that it's not running and what's the problem. So you'll see here I've executed the code with the error, and it gives us exactly the same error here, and it shows us where the error is. You will see in all our applications we are going to use variables. Variables are very important in programming. In certain languages, you specify a variable type. For instance, you say this variable can only take numbers, an integer. These variables can only take strings, text values. In Python, the variables can interchange. So you can use a variable that you declared. You can use it for a number, an integer, and then later on in your code, you can change that to use text, strings with it. It can be confusing and it can create confusion. That's why we have to name our variables accordingly and use them according to what we need them for. Let's have a look at some variables in an application. Now for this example, and from here on out, it's easier to open the folder so that we can create files as we go along. So I'm going to go to the temp folder that we created in the previous video. And I'm going to right click on anywhere on the white blank area, and I'm going to say open with Visual Code. What this allows me to do, trust the folder, and I'll have my file list here. So from here on, I can actually just create a new folder, or I can create a new file. So this is the file that we created. If we click on that, it shows the first app. Let's just fix that error that we had there before, and then we can save that. We can close that file. We can also go and say new file, and we can say declaring variables.py in here. The file's open, and now we can start typing our code into this file. Now let's look at some of the things that we can do. So one of the things in Python is a variable can be a number, but a variable can also be a string. At the same time, well, at the same time, a variable can be either a number or a string, but you can use one variable for either one of those data types. What does that mean? If we should declare a variable a equals to, this is my string test, what are we doing here is we're saying a is my variable. I've just named it a. We can name that anything we want. We can say it's a string variable as well. For now, let's just call it a. And a gets the value, gets the information. This is my string test. To run this, to see if we can print this, we can just go and say print a. Now, if everything's correct and everything's working, we press F5, we say this is a Python file, and it should execute that code, and we should see in our terminal here, this is my string test. as we can see right here. But now we can also do the following, and we can say A equals 99. And if we print A here, and we run our code with F5, we'll see that it's going to print string and a number. We've assigned one variable to different data types. We can also assign a variable to another variable. Let's look at that. If we say, let's declare a variable b here, and we don't give it any value, or we give it the value 0. If we print A and we print B here, we're going to get a blank, we're going to get a 0 because we made it 0. That's correct. But then we can say B equals A. And if we print B here, what are we going to get? A 0 or 99? We run our code with F5. And as we can see here, we get, this is my test string. That's that print statement. We get the value 0 here. That print statement there. We say A is 99. We give A the value of 99. We put 99 into that variable, into variable A. We put variable A into variable B. And we print those two. The first 99 is this one. And the second 99 is this one. Now this is just printing variables. What if we want to describe our variable in the print statement so that we actually understand it, we can see which variable we are printing now. So let's add some more text to this. This is variable A now. And we're going to print this is variable B now. If we run this code again, we'll have some descriptions of what variables we are printing. Variable A and variable B. Just to add on, if we change the value of variable A, it's not going to change the value of variable B, because variable B received whatever was in variable A here. So if you change variable A later on, it's not going to affect variable B at all. So let's print a line break here, and we say just lines so that we can see what happens. And after this line, I'm going to say A equals 44. And we're going to print A and B again after the line break. Let's execute that with F5. So we have 99 and 99. That's when that's when B received the value of A, 99. Then we changed the value of A. We changed it to 44. And the variable A is now 44. The value of 44 is inside that variable. But variable B is still 99 because that's the value it received. It's not connected to the variable of A. It received the value at that stage. And whatever we do with variable A after that, it's not going to be, variable B is not going to get the changes from variable A. We can also assign a variable like this. We can say A, comma, B, comma, C equals. This is my test. So what's going to happen now is in Python is going to assign this is to A, my to B, C, test to variable C. Let's see if it works that way. So we can say print A, print B, and print C. If we execute this code with F5, see, this is my test. If we change this a little bit around, let's say like that, and we run our code, it's going to print it in a different order. This is test. We can also assign different data types. So we can make this 9 and we can make this true. A Boolean variable is either one of two values. It's either true or either false. And we use that in our loops and if statements. We can use that. If something's true, do this. If it's not true, don't do this. But we'll get to that later as well. Just remember, a Boolean has true or false values. Let's execute this with F5. And we can see that our variables was printed true, this is, and 9. C is 9, A is this is, and B is true. Sometime in our code, we would do something. We would use a function or a loop or assign a variable or change something, and we might not know why we did that in a couple of months. What we do with coding and what's very important is that we comment our code. This allows for other developers to read our code and understand what we did if there's a complex function or a complex section in our code that could be confusing. Comments is also useful for you as a developer, where you wrote code a couple of years ago and you have to review or want to review it in the future to understand why you did something and how you did it based on that time that you wrote the code. Why do we have the comments in there? Is so that you can understand why you did it at that stage, and if you need to or want to convert it, that you can do that in the correct way so that there's no bugs. So let's look at some commenting methods. Now, when we run some code and when our code gets more complex, we would like to do the comments as discussed. Let's say we want to comment in this script, this Python application, what we're trying to do. So one way of commenting is the hash, and then we can write anything we want in there. It doesn't matter if we say print, this is my comment. Python won't execute that code. It won't show that code in the terminal. We can also go and say this is my test script to understand variables. And if I run this code, if I F5 this code, our comments won't be printed. We can also do inline comments to say, if we want to say A, we are displaying this line to test the string variable. This line will also not be printed by the Python interpreter. It will be seen as a comment, and we can execute our code and see that we don't have that comment displayed here at all. We looked at the print statement where we can write a line of code to the console, hello world, but the print function has more functionality to it. We can add more parameters to that print function to change some of the things that it does. Let's have a look at some of these. We can do more with print, where we can print separators and end-of-line characters differently. If we look at, let's clear this code here, and we take a variable, let's call this variable A and a variable B, and we assign the value, this is the values. So in variable A, we'll have the value this is, and in variable B, we'll have the value the values. And we can print it, variable A and variable B. This will work, and if we do run our application with F5, we'll see that we have the values this is the values printed. Another way of doing this, we can do print variable A and variable B, and we can add some text to it as well. Completed, for instance. If we run this, we see this is one thing with print. That's why we've got the line breaks, is one print statement will have a new line character at the back. So it will go to a new line. And that's why we have this is and the values in two separate lines. This print statement here is in one line because it doesn't have the line break in that line. It's got the line break after it printed. So we have a one line that we see here. This is the values and the completed was printed as well. We can also add another option to the print function where we can say the separator equals a comma or a semicolon or a hyphen or anything you want in there. Just for the explanation, let's do a semicolon, and if we press F5, we'll see that we've got, this is the values completed, that print statement, and the next one, the line after that, this is the values completed, but it's separated by semicolons. If we change the semicolon to a hyphen, it will be hyphens, as you can see here. As I've explained, this is the values. After a print statement, there's an end of line, a new line character. We can tell the print statement to not make it a new line, and we use the end equals to nothing option to do that. So I just executed this before I added the end. It printed this is and the values in two lines. Let's run this code and see what happens. As you can see, this is the values in one line because we added the end equals in our print function. Now in the print function, we also have escape characters, backslash characters, which we can add to do some things with the text. For instance, if we can say, okay, so let's clear this code for now, and we can say print variable A, variable B, and let's add variable A, let's add the backslash n. The backslash n says print this, but go to a new line. Now remember, when we had this initially, it printed both variables in the same row. So the top one will print this is the variables, and the bottom one should print it in two different lines. As you can see here, that's the first one. Print one line. Here we said print that, give me a new line character, new line, and the values. Now that we have an application and we can print some stuff, we might need to, or we want to ask the end user, the person using your program, to input some values in our application. This can be a name or a number, and this can be assigned to a variable. Let's have a look at the input function in Python. Now, sometimes in an application, as said, you would like to capture the user's input. And in Python, we use the input function. So if we want to capture a value from a user, we can say we use the input, and then we can have a description to say, please enter your name. If I run this code with F5, we get a prompt here that says, please enter your name. The code stopped there, waiting for a user input and interrupt. So let's type in my name, FJ, and I press enter, and the code stops. Now that's all good and well, but what do we do with that name? We didn't assign it to a variable. Now let's assign this input to a variable. Let's say name equals input. And let's print this nicely. And we say welcome name. And let's execute that code. Please enter your name. And it prints out welcome FJ. Now we have a variable. When this was running, whatever the user enters here, it will be printed here. I typed in FJ, so the value inside that variable name was FJ. Whatever the user enters into that variable will be in the variable. So if we run this code again, what's your name? And I type in 45, it will say welcome 45. Let's look at some of the errors that we can get in Python. While writing your code, your IDE will identify some of the errors that we get. Those are syntax errors, where we have a function's name wrong or a variable that's not declared. Our IDE should detect that and warn us of that. We'll look at that just now. We can have runtime errors, or generally referred to as exception errors, because it can happen only some of the times. Like for instance, if we have a number and the end user entered a number 0 and we try to divide by 0, we'll get an exception error. The compiler will still run, and if you enter the right value, it will still work. But if the end user enters the wrong value, it will crash. It will have an exception. And then we have semantic errors. When we started, I showed you guys the IDE and the errors that you can get, well, that the IDE can detect for you, the syntax errors. Let's just run through them again. So one of them is print, this is my test, and we forget to close it. That's a syntax error. And a syntax error should be, or could be, or can be detected by your IDE and give you these little underlining red lines. We also can get runtime errors, where we can say, for instance, print 99 divided by 0. Now, as a rule in math, you can't divide by 0. There's nothing wrong with this code. It is syntactically correct according to the Python, but we can't divide by 0. Our application stopped with an error, 0 division error. That is a runtime error, where your code is written and it's correct, but when you execute the code, an error occurs, and that is a runtime error. And the last error that we're going to look at is the semantic error. Now, a semantic error is kind of like a user error, where you made a mistake in your code. Your code syntax is correct. You don't have a runtime error, but you made a mistake with the calculation. For instance, let's say we want to try and we want to calculate a student's mark that he received for a grade. So let's say the student mark is 25, and the test mark is 50. So the test total marks for the test was 50 marks, and the student only got 25. So the student's supposed to have 50%. That's the grade that he should receive. Now, if we do this, the student received, so the student percentage received and we say it is the student mark divided by the test mark. That's correct. It's normal division. We get an error. This is one of those errors where the syntax is correct, but you can't add a string. You can't plus a string to a number. Now, that's my fault. I had to make a comma there. And let's just restart the code. We have 0.5. So 0.5 is not correct. It's supposed to be 50%. We can rectify this by multiplying the result by 100. But that's for a later lesson. I'm just going to show you guys that is what is meant by a semantic error. It's more a user error than a program error.